Hi, ladies and gentlemen, welcome back. This is Ms. Dubois getting my pre-algebra students ready for Goal 4. Theoretically, you are now almost done with the course. Goal 5 is so small as to be very nearly forgettable. But first, Goal 4. We got to get through that first. So, what happened to my thing? What we're going to be doing here is starting off with some easy topics. This is the first kind of group of topics that we want to focus on. More than anything else, we're trying to get you used to, exactly like the title says, variable basics. We want to get you used to manipulating numbers and letters before we can actually get you using numbers and letters. And that's what families 1 and 2 are both going to be doing. So, first things first, vocabulary, very important, ergo translating. A lot of kids will miss this on like a knowledge check or a test, but when it says translating, there's no solution here. No x equals 5 or something equally silly. What you're doing is you're taking words and you are moving them instead into an equation. The trick for this, and after I finish writing it, I'll give you a couple of seconds to hit pause and copy it down, but there's actually a list of words you kind of want at hand, a little table to use as a reference. So words for addition. So we have some increased by, you have more than, you have some increased by, total is another one, you have combined. There might be others. If we find them, we'll add them to the list. And that's why you want to keep the list on like a separate page so that you can, as you find words, you can add to them. Words for subtraction. The biggest one is probably going to be difference. And then you have the word less than. That one I want to draw a little bit more attention to because this one is hard for students to sort of translate, specifically because the translation is backwards. So let me give myself down here where there's some space. If you have 6, less than, yada, 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 this is how it translates to yada, 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 minus 6. That's the trick. This is backwards. And that's the part that a lot of kids kind of struggle with when they're first getting into how to do the translation. So something to keep in mind. That's for subtraction. Next, you have words for multiplication. And there are a lot of hidden words for multiplication that they're not going to be in this specific topic, but they pop up all over pre-algebra, algebra 1, and also algebra 2. So product is going to be specific. Product is going to be specific for this topic. Times is going to be another one. And then you get to the actual like real life word problems, miss, I don't know how to do this type. That's when you have per, you have for each, and you have for every. These 3 words are the ones that you see most often in real life, and since they show up in real life, I want to throw them into the list. Division is also really common. No, I said that backwards. Division is not very common. The word you're only going to get is quotient. And then the sign for your equal sign, you have very obviously the word equals, but another very important thing to point out is the word is, and I'm going to put that in a box because that shows up a lot. And then for my English people, anything that is a verb is an equal sign. Verb, just in case we're going to pretend that I'm an English teacher for 3 seconds, a verb is an action. So if you have, so when you total something, that is a verb. That's why you know your total means summation, yada, yada, yada. I'm not going to think of a good example off the top of my head, am I? We'll probably find them in other examples here if we do. And if we do, I'll point out to them because it's going to be a verb. But is the most important one for this topic. And let's narrow in our focus finally, Ms. Dubois. So Hans' score decreased by 24. And we know immediately what letter we're going to use. So Hans' score decreased by 24 is 60. And you can kind of see them box up and take all of their different places. Decreased by is, and then you're 60. So let's do that actually a little bit slower now that I'm paying attention to this. Let me erase all of this and actually make a decent box this time, Ms. Dubois. There we go. And then split, decreased by, split. Okay, so Hans' score, that's the unknown, that's the variable, so that's your H. Decreased is your subtraction. Decreased by what? 24, that's how you get the minus 24, is, like we were talking about before, is your equal sign, and then 60. Same thing over here. You drop it into a box and you separate it out. 65 is, there's your thing, difference of, so we know there's the subtraction, and what are we subtracting? Victor's age and 18. Now this one's going to look a little bit differently because you can see the boxing, the difference isn't between the two variables like it is over here. So 65 is the difference of Victor's age and 18. So now the pieces still line up. It works pretty well, but this is an example where one of your boxes is a little out of place, and that's something to keep in mind. I will say about 90% of these sentences you're just translating from left to right, but because they do throw on us out of order, you want to be careful. Let's look at this one. I think this one's more straightforward as I recall. The product, okay, so it's like this one. Product of Hans savings and 4 is 68. So product of Hans savings and 4 is 68. And each piece breaks down. Product tells you the operation. The following two boxes are the pieces of your product. Pieces of, quote, product. That way you know what two pieces you're putting around your multiplication symbol. Hopefully that will help simplify what you're looking for. Now we're going to scroll down a little bit, and now we start to get used to the actual algebra. So multiplying a constant. So you're going to see this a lot in math language. Constant is a fancy word for a number. Monomial is some, I'll call it a letter number combo. Letter number combo, so that the vocabulary will make sense. So here, that's a number, that's a constant. Here, that's a letter number combo, that is a monomial. And the thing here is that the letter is not used yet. Variables kind of are inert. There's a science word. Variables are inert unless there's an equal sign there. So whenever you see something like, you can kind of see as you trace your way down all of these topics, none of them have an equal sign because we're not looking for you to get an x equals. We're not there yet. That's an ixnay. What we're looking instead is to get you used to manipulating and moving things around when there's a variable there. So when you actually do have the equation, you're not scared. So here we have that 3, and it actually tells you what the direction is. When you have a 3 in front of a parentheses, or you have any number really in front of a parentheses, that is a sign that you're doing multiplication. Multiplication. I can spell. There we go. So 3 times 3 is 9. The W, because we're not using it yet, simply drops down because we're not ready to figure out what W is at this moment because there's no equal sign. Same thing over here. 4 times 7 is 28. The C is not used, so it drops down, 28C. 3 times 5 is 15. U isn't used, so it drops down, 15U. 6 times 3, that's a little bit scary because the 3 is on the wrong side, but it is still multiplication. You're doing your likes with your likes. So 6 is the same as 3 because they're both numbers, aka they're both constants. They look like earmuffs. 6 times 3 is 18, and then the C drops down because we haven't used it yet. That's what they're getting us used to doing. Scroll down a little bit. Now, the next several topics, you're going to see this word right here, distributive. Any Algebra 1 person worth their salt is going to say this over and over and over again. Pre-algebra, it's still new to you, but you want to know what the word actually does. So, distributive property is when you have a number in front of a bigger set of parentheses. And because you're still multiplying, you're going to multiply it by all of the pieces inside your parentheses. So over here, we have 4 times V. That's 4V. 4 times 6, that's 16. That's what they're getting you used to doing. If it is separated by a plus or a minus, then whatever's inside of it is going to get multiplied. Over here, 4 times Y, 4Y. 4 times 9, 32. 6. And you've done in goal 2 enough multiplication to know that the 9 is negative, and ergo the subtraction falls down as well. Here, oh no, the horror, the 7's on the wrong side. Oh, no, 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 it's fine, because we doesn't change anything. So 7 times u, 7u. 7 times 5 is 35. So what this is, actually, I almost want to label this as a goal 2 topic where it's a lot of just multiplication and division, but because the variable is there, it gets shunted into goal 4. Let's see here. Now, look at this. Oh no, there's exponents, miss. What am I supposed to do with all of those exponents? The horror, the horror. Except, like I said, variables, we're not using them yet, and that also includes the exponents. We're not touching them yet. We want to keep the variables, we want to keep the exponents where they are because it's not Algebra 2 yet. Exponents there are there visually to get you used to them, but they're not actually going to be used until much later. So multiply again. 5 times 2 is 10. Negative times a negative is a positive. Y squared wasn't touched, it drops down. 5 times 6 is 30. Negative times a positive is a negative, and there's no variable. 5 times 6 is 30 again. Negative times a negative is a positive. V cubed was not used, and so it drops down, and that's going to be our final answer. Same thing over here, -4. You'll also notice they don't always do it in the beginning stuff, but you notice how that -4 is in parentheses. That actually pops up a decent amounts in Algebra 2 especially, but just barely. You get a blush of it in Algebra 1 as well. So we're going to do distribution. 4 times 4 is 16. Negative times a negative is a positive. 4 times 4 is 16. Negative times a Negative times a positive is a negative. V was not used, it drops down. 4 times 2 is 8. Negative times a positive is a negative. Y was not used, it drops down. And now again, -9 times -3 is positive 27. The V squared drops down. 9 times 2 is 18. 9 times 5 is positive 45. And then Y cubed drops down because we haven't used it yet. So now I want to draw your attention to the fact that not only are they throwing variables at us, but now also with the exponents, and we haven't touched them. All they do is drop down when we're done doing the number manipulation. And that's all variables and exponents kind of do for the most part. They just kind of sit there and vibe, and they don't really intercede until it's their turn. They're very patient in that respect. That's why I like them. All right, distributive property, fractional exponents. Fractions. 6 times 1/2. I'm going to show off a little bit because I know I'm letting all of my pre-algebra kids use the scientific calculators, but half of 6 is 3, x drops down. 2/3 of 6 is going to be 4, and again, if you need the magic of that, 6 times 1/2 becomes 1/3. That's where the 3 comes from. 6 times 2/3, 2 times 2 is 4. That's how I'm doing it. Now, theoretically, this visual piece right here, you've had exposure to in goal 2. If you don't see that before or you've forgotten it from last year, ask me and I'll show you in more detail in your notebooks so that you have it there as reference. 20 times 1/5. So 20 times 1/5, that's a 1, that's a 4. So it will be 4u, which somehow makes me write a y. Then you have 20 times 3/4, so that becomes a 1, and that becomes a 5. 5 times 3 is 15, and then that's a negative. 20 times 5, didn't we just do this? Oh no! Oh, I double copied the screen grab. Look at that, it's the same number. Oh, that's frustrating. All right, let's make up a number then. Let me dip up the opacity here. Nope, I did that wrong. And then let's make up a number as we go. So let's say instead we can do 1/4 times. What's something I can do easily in my head? We can do 8, or no, these are supposed to be fractions, Ms. Dubois, pay attention. So we can do 8/5 x, or wait, these come into whole numbers, don't they? Okay, so we'll do my brain just stopped working, and that's why, because it's 1/4. I put the fraction in the wrong spot. Gosh darn it, Ms. Dubois. Honest to Jiminy Cricket. 5/4, and then we'll say plus 3/2. There we go. New example. See? First try. I didn't struggle at all. What are you talking about? We have 8/1 times 5/4. That cancels to be a 2, and 2 times 5 is 10x. We have 8/1 times 3/2. That cancels to 4. 4 times 3 is 12. That's what you're doing. And reminder, I'm going to be giving you guys access to my scientific calculators in order for you to do the fraction math a little bit better for you. Now that we understand variables exist, numbers exist, they kind of have names, constants and monomials, and now we're going to get into more definition stuff. So I'm going to give myself actually a little bit of space here. Let me erase a little bit. So we talked about this before. Constant is a number. Let's see here. What are the words they're looking for? Factor. Let's see here. 5b is a factor. Constant. Coefficient. Coefficient is the number in front of a variable. Number in front of a variable. Let me write an example of that. So if we're looking at 6x, 6 is my coefficient. I can write that as a shorthand, right? That's perfectly fine. Let's see. Factor, Scooby-Dooby-Doo. Oh, no, wait, I'm not in high school anymore. Oh, there was a jingle when I was in high school. Factor is something being multiplied. So over here, that 6 in front of the parentheses over here, that was your factor. So something being multiplied. Let's see here. Coefficient. Like terms. The important thing here is you need the same letter and exponent combination. That requires a little bit more explanation, but we're actually going to see a good breakdown of that in these examples. So let me get more comfortable in my chair. All right, so let's talk about terms for a second. If I look and zoom in at this particular problem, you'll see that there's 3 distinct pieces of information, the 5v, the 3u, and the 2. Each of those is considered a term. So that's a term, that's a term, and that's a term. That's what we're looking for here. That's how you break things down. So if I'm looking at, let me rewrite this, and I'm going to change one of the letters to make it easier. 5v plus 3v plus 2. If I look at this term, 5v, and this term, 3v, they have the same letter, the letter v, and they have the same exponent, which in this case is none. And because of that, they are considered like terms. That's the crux of like terms. That takes a while for kids to sort of understand. So like terms is the same letter and the same exponent combination. It takes a while for kids to absorb. So they're going to throw that at you for a couple of times in this topic, and now you know what you're looking at. Now, 5v, factor. Factor is something that being multiplied. Is 5v being multiplied by anything? No, that's not it. 2 is a constant. Constant is a number. Yes, check that off. 5v and 2 are like terms. Okay, like terms is the same letter and the same exponent. Well, 5v has a v. Does 2 have a v? Nope. Ergo, ixnay, cross it out. 5v is a coefficient. Ooh, coefficient is number in front of a variable. Nope, this one is an ixnay. If they just said 5 is a coefficient, then it would be okay because 5 is indeed in front of the variable. But the minute they input that v, it's a false because you can't have a variable in a coefficient. There we go, multitasking. All right, 5v plus 3v plus 2 is written as the sum means addition, of 3 terms. 1, 2, 3. This one's a yes. And then none of these are true. Doesn't work because we found 2 that were true. Now, again, next box, we're going to break it down. You'll notice that there's 1, 2, three terms here, the 5b, the 2a, and the 1. 5b, 2a plus 1 is written as the sum of three terms. Yes. 5b is a factor. Nope, because it's not being multiplied. 1 is a constant. Yup, because that's a number. 5b and 1 are like terms. Nope. One of them has a b and the other one doesn't. That's why it fails. 5b is a coefficient. Nope. 5 is the coefficient, not 5b. That's what makes the difference. Then, here we go. Here's something that has some factors. This will be fun. All right. In parenthesis, in quantity 2u plus 7, 2u is a constant. What is a constant? A constant is just a number. So no, that one's not a constant because it has the u. It's the u that makes it fail. In 2u, 2 is a coefficient. Yes, finally, they said it right. Then what else? 5 is a factor. What does factor mean? Something being multiplied. Is 5 being multiplied? Yes. 2u plus 7 is written as the sum of three terms. So it is a sum, but I only count 1, 2 terms, not 3. So the computer can't count, the poor thing. 6 and 1 are like terms. What's like terms? Same letter, same exponent. 6 doesn't have a letter. 1 doesn't have a letter. Checks out. Therefore, whoops, it's a like term. Ta-da! Hey, this one had 3 right. Yay! Happy days. So again, much like up here at the beginning, where you need kind of a table as a reference, down here, you need these written in your notebook to constantly read the definition of until you have it like memorized and internalized in your blood like I do. Now, let's see here. Identifying equivalent algebraic expressions. Now we start getting into it, just barely touching the manipulation stuff. If you will notice, based on like terms, we'll remind you, like terms means same variable, and exponent combo. They're not really going to give us exponents here, but I want that in there because I know kids will get confused later otherwise. So we have x, x, x. That's the same letter. Therefore, these are like terms. And here's the cool part. Because they're like terms, we can combine them. So what is 10 minus 5? 5. What's 5 plus 3? 8. Is there an 8x anywhere here? Yes. And we can also do that in a different way as well. Because we did that in 2 steps, let me write that out for a second. 10x minus 5x plus 3. 3x, Ms. Dubois. 10x minus 5 is 5x. And then 5 plus 3 got me the 8x. So now here's the trick. This worked, and now this also works. Is that 5x plus 3 somewhere? Yes, it is. And that's how we know that we've completed everything in our list. Now, what else do we have? We have 4, 1 plus 4y. I remember that. That's distribution. We did like a billion topics on distribution, so I know what to do. This is a multiply problem. 4 times 1 is 4. 4 times 4 is 16. The y didn't get used, so it drops down. So 4 plus 16y. Now, what I'm going to do is show that extra work that I didn't do up above. So I'm going to move this down a little bit. And now what I did is I did 4 times 1 and I did 4 times 4y. This particular step, Ms. Dubois almost never writes. My mental math is strong enough that I can kind of low-key do it in my head, or high-key do it in my head, I'm not sure which. But these are the 2 pieces that I'm looking for. 4 plus 16y, there it is. What else? 4 times 1 and 4 times 4. 4 times 1, nope, that's not it. 4 times 1 and 4 times 4. There it is. Those are the 2 options we're going to be picking. Now, what else do we have? Let's see here. We have, let me erase this so I have space to work. Delete. Okay, so now we have x plus x plus x plus x. That's our next one. And my handwriting is terrible. We're going to ignore that. We have like terms, same variable combination, x, 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 x. Yep, absolutely. So I have 1, 2, 3, 4 x's. My final answer is going to be 4x. There it is. Is there any other way I can write this? I mean, technically, I suppose you can do 2x and you can do 2x. Is there a 2x plus 2x here? Nope, that one's subtraction, so it's not going to be that one. So that's all we've got. That's as much as we can do. Okay, not so bad. And now for the last one, what do we have? We have 56y minus 32. Now this one can be legitimate hard for students because what you need to do in your brain is kind of do distribution in reverse. And not everyone, because their math facts might be weak or maybe they haven't seen it in a while from Goal 2, they might be a little bit hard to sort of see. I'm looking at these numbers with my human calculator brain, and I know that we can divide by 8. And I know that we can divide by 8. There might be a better number, I'm not sure, but let's go through it and see what happens. What I'm going to do, the phrase for this, you'll hear teachers say is you're pulling out something. So what I'm going to do is I'm going to pull out that 8. And what ends up happening when I pull it out is that it starts to become parentheses. And oh, look, this looks like distribution just in reverse. Okay. What is 56 divided by 8? That is, of course, 7. Y drops down because we didn't use it. What is 32 divided by 8? Ooh, moment of thought. That's a 4. So is there anything that looks like this? Yes, there is. Is there anything else we can do? 8 is the biggest number, and that's the preference. We can also do distribution, I think. So we can do 8 times 7y. And then we can do 8 times 4. Would that be here? I'd be shocked if it was. Oh, no, I am shocked. There it is. I was not expecting that. What else could we do? I mean, like, technically, 8 is the best number, but we can divide it by other numbers. Let's see. If I do 56y minus 32, and I divide by... Instead of 8, let's do, like, 2, maybe? Divide by 2, because that's the smallest number. This one was the best number because it was the biggest, but let's try something smaller. That becomes, what's 56 cut in half? That's going to be 28. And then what's 32 divided by 2? 16. I doubt that's up there. Oh, except it is. All right, so this is the one where kids will get a little bit stuck on, because you'll notice I did the one thing that I knew immediately was going to be here, because this is the thing that happens the most often. This is the thing you're going to see the most. But even though I did that and had that thought, there are the extra steps, because there is the distribution angle. You could also cut it by a different number, and that's what makes this type a little bit tricky. The other ones are low-key kind of simple. It's just a question of how good you are at simplifying. And so that covers everything for Family 1. Now we understand the basics of variables. We have some very light manipulation, but before we get into that, the next video is going to be all about like terms. We've introduced them briefly, and now we're going to kind of dig into them wholesale for the next video. As always, stay happy, stay healthy, stay safe. I'll see you in the next one. End transmission.